So, walking by the thermostat, I'm greeted with this: system malfunction, call technician. Well, when you're a do-it-yourselfer, guess who you're going to call? You're the technician. Yeah, this is the Evolution system from Carrier Bryant. Ever since we put it in, it's caused nothing but problems. Here we go again. So, let's start into the diagnostic. So, just going by the thermostat here in its diagnostics, we've got two faults. The first one that's showing up is a error 41 blower motor fault, and the one after it is a high pressure switch open. I'm guessing the high pressure switch one is because the blower motor is not working. This is a heat pump because there's no air flowing past the coils down in the furnace, or air handling unit if you want to call it that. It's tripped the high pressure switch as well. Obviously the motor one is active right now, it's flashing. Now we get to start tearing it apart and finding out what's going on. Okay, we're down at the fan coil. I've got the inspection cover off, and I don't know if the camera's picking up this noise, but the motor's just pulsing. It's not turning the squirrel cage inside. It's just making this rumbling, pulsing noise. And then if we actually go up to our control board, if you don't have a communicating thermostat, you can also read fault codes on most modern new furnaces or fan coils. Right on the motherboard there'll be a status LED, and it will indicate codes. And in this particular one, it gives short flashes for the first digit of the code, long digits for the second. I'll just wait till it starts cycling again. 1, 2, 3, 4, 1. So error code 41, just like we saw up at the thermostat. So again, if you don't have a communicating thermostat, that's the other way you diagnose these, is on the control board you'd read off the fault code that's flashing. So the one thing that's kind of cool to get these out, they've made it really simple. You basically just take this bar off at the front, oh, that's not good. Lost in the abyss. And now that that's out, you just got to cut this little zip tie off. Don't cut through the wires, of course. Something I like to do all the time. And you just take, now this whole thing can slide out. And you just have to unclip these. It's not the lightest little turd, but ooh, those are sharp. Come on, get out of there, you piece of crap. There's one out. Okay, this one's using side tabs to lock the plug in, of course. Wouldn't be something simple. Gotta get it out a little bit further to get my fat grubby paws in there. Oh no, that you just squeeze together. So that's how you take her out. In the bowels of the beast, remember that screw that went into the abyss? There she be. And you get your old magnetic sticky wand out, and there we go. You got to get these screws when they fall down because you forget about them. So with the blower assembly out, we can get at the ECM here. Now, I've already looked, I've got the actual repair or service manual for this furnace. You can find them online. And they say to check these. Before you can condemn either the ECM or the motor, you have to do a couple of checks. But to get the ECM out, you just take these two long bolts out. This will lift off of the back of the motor. And there is a little wire that, well, it's a 3-prong wire. You have to take that out. There's a little plug in here. Come on, you little rascal. Haskell. There we go. So again, 3-phase DC motor. There's our 3 wires, like many of us RC people are familiar with on our brushless 3-phase DC motors. So before you can condemn anything, the first check is to see if the motor is actually turning. You could do that even before removing the ECM module, of course. But as long as the motor is turning smoothly, you know the motor's not jammed. Error code 41 means the computer in the furnace is not seeing that the motor is turning. So it's turning fine. So that's the first check, the first physical check. Next check on the motor is to check if there's any shorts or if there's any opens in the phase windings. And to do that, first thing you do is make sure there's no continuity between any of the 3 phase wires and the case of the motor. So you don't want to see any continuity, you want to see infinite resistance on all of these. And that's what we've got. In the service manual it says you want to see between, I think it's, what is it, between 1 and 100 ohms, I think, between any of the coils, and they have to be within 10% of each other. You probably can't see the meter here, but I'll put it up there. So on this one we've got 10.2 ohms and 10.2, go in the middle, 10.2, 10.2. So I would say they're definitely all within 10% of each other. They're all bang on. So the coils aren't shorted to the motor, they're not open or have a higher resistance. So we know the motor's good, so we have to start suspecting our ECM here. So we'll go to the bench and start checking that out. Okay, now that we've got the ECM out of the motor, I thought we'd just take it to the bench and show you. There's a few things that you can actually check on these. You have to unscrew this top circuit board. You have to be careful when you first take this off. These 2 big 1000 microfarad caps, they can store voltage for a little while, and you could get some hair curling electrons coming off of them. So either discharge them if you know what you're doing, or just let it sit for maybe 10-15 minutes and they'll just self-discharge on their own after you unplug it from the main power source. What this board is, these are pretty neat actually. If for us RC, electric RCer guys, radio controlled guys, what we've got here is basically an electronic speed control that we use with our brushless motors in our planes and cars and helicopters and quadrotors. This board on top, this is an AC to DC converter board essentially. In my case, your main power from your furnace plugs into here. For me, it's 240 volts AC. We've got a coil here, a couple of polypropylene caps. This is a inrush current limiter, very similar to what you'd see in a cheap power surge bar, like a surge protector power bar. And a lot of times these apparently will go. So that's one of the first things you can check. If you have a multimeter with a continuity tester, you can check the continuity between the 2 leads on this little inrush current limiter. It's kind of like a fuse, works differently, but it has the same purpose. When these blow, usually one of these leads will be blowing right off of the face of it. Another telltale sign is if the leads are all burnt, like the solder traces. That's a good sign that this thing's shot, but in this case that's not the issue here. Everything else looks fine. Here we've got a bridge rectifier. What number is that? Is it a D25 XB60, I think? That's a pretty common one. You could suspect that, but one way, if you know what you're doing, what you can do is plug this back into the furnace plug, turn the breaker back on so you've got power going to it. Put your multimeter on DC and check your voltage at these 2 outputs these 2 wire outputs. And if you're getting power on those in the DC, in the DC range, you know that this board is working okay. And I've actually already done that, and I was actually getting 320 volts from here. So not only is this converting it to DC, it's stepping up the voltage a little bit. And like I was saying, for us RC guys, we actually probably know more about these things in a sense than the actual field tech, the HVAC field technicians. What we basically got here is an ESC, a three-phase DC motor ESC, electronic speed control. You can see the similarities. There's our power caps. Basically same thing as these, just bigger, higher voltage. This is our positive and negative feeding the ESC, just like our positive and negative that's coming from our battery packs. Down here, again, big power caps are needed because, like we all know, MOSFETs hate dirty voltage, and that's what these are doing. They're smoothing out any voltage ripple, giving it really clean DC voltage. So what we've got here, here's our three-phase MOSFET bridge for our three-phase motor. 2 MOSFETs per phase. If you remember when we took this out of the off of the motor, there was that 3-prong plug from the motor, from the 3 motor windings, or from the 3 wires in the motor, just like our 3 wires coming from our ESC here. And inside here we'll have a microcontroller, a bunch of other little devices. They're all bathed here in a silicone bath, which is solidified, so we can't even get to it to test it. Obviously, if one of these MOSFETs were blowing up, you could see, but they could be shot. We have no idea. We can't get down to test them. But they're on a pretty big, they must be working pretty hard because they're on a heat sink. Anyway, so that's what you can test on these. You can test this board, and you know what I'm probably going to do? I'm going to keep this. I know this top half is working, so you know, keep it. If you have to get a new one, a whole new ES or a whole new ECM, and then you can use it, you know, if your other one goes, if one of these goes or the rectifier goes, whatever. Again, do-it-yourselfer kind of stuff. I've already done some checking. This is the ECM 2.5, and they don't make them anymore, as I feared, or as I suspected and feared. However, I did find a service bulletin. Just going to zoom in here a bit so we can see what we're talking about. So this is a service bulletin from Carrier. It's DSB 090001, and it pertains to ECM 2.5 and 3.0 replacement motor controls. Perfect. And it says the model of furnaces or fan coils that are affected. And here's mine, a Bryant FE4ANF. So this pertains to that. The issue or the situation they're saying, new service replacement motor controls will soon be available for ECM 2.5 and 3.0 motors. I'm thinking, oh great, there was obviously an issue with them from the get-go. I still kind of think that, obviously because of the problems I've been having. They're saying they're doing this so they don't need 6 different, you know, a lot of modules to stock for the for everyone. Now they're just reducing it. So that's why they've come out with this. Hopefully they're better modules. Second page just shows us the ECM 2.5, which the plug configuration, which we've got. We'll just plug put that back in there. So yeah, that's exactly what we've got. And we're going to an ECM 3.0 control. And then it says down here at the bottom, it shows what part number our old motor and ECM 2.5 was. It's an HD44RE120. When I look online, can't find them anywhere, not even used. Just the ECM is an HK44EA120. That's the ECM 2.5. Again, can't find them. But it has been replaced with the HK44EA123 ECM. This is actually a 3.0 ECM with an adapter ring and an adapter plug. So it will fit on my old motor, and the adapter plug will take this bottom plug that went into this side from the furnace into this new, just this little 4-pin plug at the bottom. And actually there are only 4 wires that go into this. I don't know if you noticed that when I took it out of the furnace, so I don't know why they've got all these. Must be for different configurations, who knows. But anyways, that's what this thing is. Funny thing is, when I looked at this online, they range in price from about $600 to $800 down in the States. Up here in Canada, I can almost guarantee you it will be at least double that, if not more, which is absolutely outrageous. Even $600 to $800 is ridiculous. Remember, we used to replace furnace motors, a 3-speed AC furnace motor, for like $150 to $250, depending on how many horsepower. Half horsepower one should be under $200. But those days are gone. This is progress. Anyways, what I was getting at is you can get the whole new motor and ECM. Part number is 58MV660001, and it's actually not much more expensive than just the ECM. So if I'm forced to have to buy or spend over $1,000 to fix this thing, I think I'm just going to get the motor and ECM combination. You know, if it's only $100 more, it seems silly to buy just the ECM. But I'm going to keep looking around. There are a lot of ECM 3.0 O's out there, and you can get them for pretty cheap that are not these, that don't come with these adapter rings or anything. Obviously I'm going to need this adapter ring for it to work, but I'm going to check around. I just thought someone might be interested in that if you've run into one of these as well and you've got an ECM 2.5. Looks like we can get a replacement unit, but it's going to be expensive. Anyways, that's it. I'll get back to you when we get the part in. So, 2 weeks later, hopefully, our ECM is here. I actually found a used one. It's supposed to be the 3.0 with the converter ring. So let's see what it comes with here. And basically $100. And if this works, I'm just going to order up maybe 1 or 2 more ECM 3.0s. So I've always got a spare one here. So we don't ever run into this issue again. But it looks promising. The ring's already on there. The adapter ring. And the plug. Looks like it's been through the war and back, but again, this is just testing this out. Yeah, if I couldn't have found a used one, yeah, I just would have bought a brand new one probably. So this is the ECM 3.0. What was that? GC08, half horsepower. And so yeah, we'll install it and see what happens. Hopefully it'll work. But now at least, if it does work, I can just get these ECM 3.0s. You can find these online really cheap now. Yeah, if I have to replace one every 5 years, so be it. Before installing this rascal on the motor and fitting it back into the fan coil, I just thought I'd quickly go over identification numbers that are on the back of these things. And this is really important when you order them. And it does take a little research. If you're buying them from a reputable seller, it's good to ask them the question of if this will actually work in your fan coil or furnace before purchasing it. The eBay seller that I bought from, very helpful, really knew his stuff. So, you know, he assured me this would work. The programming's right. You know, it's half horsepower, and the GC08 numbers apparently pretty critical. I don't know. I'm not an HVAC tech. I don't know if that's a programming level or what, because there's also a GC07 and maybe something else as well. One thing though I did find, which is really helpful, I'm going to put a link to it down in the description box below the video here, is I found this Gentech ECM service guide PDF online, and I'll link to that like I said. It's 58 pages, really informative, goes over what these do, the way you identify them, their history, their evolution, and all the checks that one can do on one of these. It's meant for the service technician, but you know, it's a good diagnostic tool. So it is kind of interesting, the difference between the ECM 3.0 and the ECM 2.5. I don't have that little spacer ring on here now. As you can see, it's quite a bit shorter. And everything's also contained in the silicone bath here. No longer does it have a separate rectifying board converting the AC into the DC voltage. It's all built into the one unit. So my thought of, you know, saving this board for future use, probably not going to happen. So I'll probably just junk this whole thing. But one interesting thing is this whole thing now is made out of cast aluminum, so it's going to obviously act as a better heat sink. Component wise, yeah, you can see some similarities. There's the big coil, there's the two polypropylene caps, there's that inrush current limiter, the rectifying bridge, or the bridge rectifier, and there's our MOSFET three-phase bridge, I would assume. Looks like they've gone to one solid state device that's got a good amount of heat sinking right to the case, and there's bigger cooling fans there as well. So hopefully this is an improvement, and it will last longer than these ones, which like I said, the first one I had lasted just over 5 years, just outside of the warranty, and Bryant basically told me to go pound sand, not to mention the service charge I would have been presented with by the service tech. So I found one of these. This is the second one, and it lasted for just over 5 years. So don't know if that's typical or not. If anyone wants to leave a comment, if they've got an ECM 2.5 on the half horsepower motor, it'd be interesting to know what people are getting out of them for lifespans, and if the ECM 3.0 is an improvement on that. Anyways, better get her onto the motor now. Okay, so we're at the blower unit with the motor. Here's our old ECM 2.5, and as you can see, the new 3.0 with that spacer ring is basically the same height, so we can use the old bolts that we used when that were in for the ECM 2.5 to attach this one. Hookup is basically the same as we took out. We've got the 3-prong inlet for the 3-phase DC motor plug. Plug that in. This new spacer ring, it's got the little notches for the holes that line up. There's little tabs here that little notch has to go into. And make sure, so the connector's on the back side. This is the front side of the blower housing. Just start those by hand. Tighten them evenly so it snugs down. Okay, so it's on. We'll plug that converter plug in right now. Okay, and we'll take this to the furnace and hook it up. Okay, so we've got the blower housing here. And we'll just plug our connectors in. Sorry for my big fat head being in the way. And then there's our adapter. I'm just going to push that in there so I don't have to hold the weight of it. So there's our adapter plug from the, so the ECM 3.0 fits the ECM 2.5 plug. And then we'll just slide this in. Easier said than done. Come on, you little rascal. There we go. So I'm just going to zip tie. We'll get a zip tie. We'll tie the wiring off. We're going to have to remount the bar. But I'm I'm just going to pause the camera. We'll look at the board while you turn the circuit breaker back on. Okay, so we've got the new ECM installed, and we've got the furnace housing, or the blower housing, in the fan coil here, or the air handling unit. I'm just going to run to the circuit breaker real quick and turn it on. I've already got the thermostat set to turn the fan on at medium-high speed. So I just turn the breaker on. Let's see what's going on the board here. So we've got the status LED lit up, no more fault code. Communication green LED's on. Now we just got to wait for the call for heat. There's a little LED at the bottom for the motor call. It's flashing. Wait for it. Wait for it. Ho ho! There is a beautiful sound. The fan is working again. Ho ho! So there you go, folks. With a little research, a little know-how, and a little patience, we just avoided at minimum, 1,000 Kanakistan dollar repair. If I had to actually get a service tech way out here, likely at least $200 to $2,500. Got this off a good old eBay for under $100 US. By the time it shipped here and landed here in Canadian dollars, it was $130. Yeah. So, not saying this is going to work for everyone, but I just wanted to show you this little video because, as I mentioned before, I've had nothing but issues with this furnace. Now with this new ECM 3.0, hopefully it's going to last a little bit longer, but you can be sure that I am ordering another one right tonight, so I've always got a spare on hand, and I'm never going to be scared to run this fan continuously like we always used to with our old AC motors. And again, the motor is fine. These brushless motors rarely go out. It's the ECMs in them. Yeah, so we're good to go. Hopefully some of you found this useful for your own information. And again, do-it-yourself repairing. It can save a lot of money. Cheers, folks. Have a good one.